Okay, so we are starting our factoring unit, guys. Factoring is essentially the exact opposite of what we did last unit. Last unit, we went from having things multiplied together, and then we got rid of the parentheses by multiplying. And then we had like terms we added and subtracted. This unit, we're going to go the opposite way. We're going to have terms that are added or subtracted together, and we're going to turn them into things we're multiplying together. Factors are things that are multiplied together. Okay? So, we are starting with our greatest common factor. It says the greatest common factor is the product of the greatest integer and the greatest power of each variable that can divide evenly into each term. Do we remember doing GCF before? Like previous years, you did like a factor tree, and then you found all the common factors, and then you multiplied them all together to find the largest number, the greatest common factor with the two numbers. Does that bring back a little bit of memory? If not, lucky for you, we're doing it again today. Okay, so the reason that we have been listing out factor pairs on our calculator is because today we are finding the greatest common factor, which means we need to know how to find factor pairs. If I'm finding the greatest common factor of 18 and 27, I'm going to do 18 divided by x on my calculator. Make sure you're doing this with me. So we are going to list out all of our factors of 18. So you go to y equals, do 18 divided by x on our calculator, and then what pulls up the factors? The table. So second graph, we always start at 1. So I have 1 times 18, 2 times 9, 3 times 6. Then I get a decimal, and then 3 times 6. I already have 3 times 6 on my table, or my factor pair list, so am I going to write it out again? No, good job. Now I'm going to list out factor pairs of 27. Go to y equals and do 27 divided by x and go to your table. Again, always start at 1. 1 times 27, 2 gives you a decimal, 3 times 9. Then I have a decimal, 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 decimal. And then I have 3. Well, what is 3 paired with? 9. I already have 3 times 9 on my list. So I'm done listing out my factor pairs. So now I'm wanting to find the largest number that's on both of my lists. Okay? What's the largest number on both of our lists? 9. 18 is divisible by 9 and 27 is divisible by 9. Are they both also divisible by 1? Are they both also divisible by 3? But out of 1, 3, and 9, because they're both divisible by 1, both divisible by 3, which one's the largest number? 9. So 9 is my GCF, and we are done. Okay? We go with that? What does it mean if 9 is my largest GCF? When I divide 18 by 9, I get 2. Not subtracting. Divide. So we get 2, and then when I get 27 divided by 9, I get 3. Okay? So both 18 and 27 are divisible by 9. And when you divide out the 9, you get 2 smaller numbers. Are we good with that? Yes? Next, 24. We're going to list out all of our factor pairs of 24. 24 divided by x. Then go to the table. 1 times 24, 2 times 12, 3 times 8, 4 times 6. Then I get 5, but that gives me a decimal. And then I get to 4, but that's 4 and 6. I already have 4 and 6 on my list. So I'm done listing out factor pairs of 24. Now we're going to list out factor pairs of 60. 60 divided by x. Why are we not all doing this? So 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10, decimal, 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 6 times 10. Do I already have 6 times 10 on my list? So we're done looking at listing out factor pairs. Now, are they both divisible by 1? Are they both divisible by 2? Are they both divisible by 3? Are they both divisible by 4? Are they both divisible by 6? Are they both divisible by 8? No, 8's not on this list. So far 6 is my biggest number. Are they both divisible by 12? 12 and 12. Are they both divisible by 24? No. So what's the largest number on both lists? There is your GCF. Done. Good? That's nothing new. I might have showed you a different process on how to do it or a different method on how to do it, but you have found GCF before. Now we're going to incorporate variables, okay? So, what does an exponent tell you? If you have an x squared, what does that mean? What's x squared mean, guys? Come on. X times x. You have x twice. You have 2 x's. So, I'm going to write this out as x. Now this y, does it have an exponent? No. So do I have it multiple times or just once? So I'm just going to write it once. Then what does x squared mean? X. What's y squared mean? Y. What does x mean? Just an x. We all awake, guys? What does y squared mean? Y. Okay? So, I only want to circle what's in common. This, I now only am using variables, and there's also 3 terms I'm looking at, not 2. When we did our numbers up above, we were finding the GCF of only 2 numbers. Now we're finding the GCF of 3 terms. Okay? So, in order for it to be a GCF, or something in common, all 3 of the terms have to have it, not just 2. Okay? Do they all have an x? Yes, so they have an x in common. Do they all have another x in common? Does this have an x? Does this have an x? Does this have another x? No, so I'm done with my x's. Now, does this first one have a y? Does this one have a y? Does this one have a y? So they all have a y in common. Does this one have another y? No. So do they all have another y in common? No. So what's the only variables in common with all 3 of your terms? X and y. There's your GCF, x, y. McCalls, hi. We're doing this with me, guys. Again, factoring, students historically struggle with. Factoring never goes away in all of your maths. We are currently factoring in geometry honors. Okay? You factor again in algebra 2. You need to know how to factor. So I'd make sure I'm paying attention. Okay? We good? So we did numbers and we did variables. What do you think our next option is? Numbers with variables. Well, how are we going to do that? We're going to pretend our numbers don't have the variables, and we're just going to look at the numbers. So 18. If you're resourceful, we already listed out factor pairs of 18. Right, Patrick? So I'm just copying down my 18 factor pair list. And we're also going to be resourceful because I already listed out my 27 factor pair list. So I'm just copying that down from here as well. So what was the largest number on both of those 2 lists? 9. So 9 is my numerical GCF. But now I need to look at my variables. Here I have an x. Here I have an x squared. What's x squared mean? XX. So what's in common? Do they both have an x? Circle an x, circle an x. Do they both have another x? No. So my GCF is 9x.
Why is it not 9x squared?
Does this one have an x squared? So you can't take out more than what both of them have individually. We're not multiplying these, we're taking out what's in common. Just like my GCF of 18 and 27 is not 81. I'm not multiplying the 9 with the 9. I'm saying, what are both of these divisible by? 9. That's what's in common. They both have one x, so I have an x to the first power. Okay? How do we feel with just finding the GCF? Okay, next we are going to factor by removing the GCF. No longer are these like a list of numbers. Okay? It says to identify the GCF, that's why we did that up top. That's your first step. You have to be able to find the GCF. Then we're going to divide out the GCF. Then we're going to write your answer as the GCF times the remainder. Okay? So, first step. Is there a numerical GCF? I have a 2, and what's this x's coefficient? 1. What's your GCF of 2 and 1? Is 1 divisible by 2, though? Is 1 divisible by 2? Because think, if I do 1 divided by 2, I get a decimal, meaning it's not divisible. Okay? Your factors of 1 are just 1 and 1. Okay? So, is there a numerical GCF other than 1? No. 1 is your GCF. Do they both have an x? Do they both have an x squared? No. So what's my GCF? 1x. And you can put the 1 there, but do you need to put a 1 with a variable, a coefficient? No. So I'm just going to put x. Okay? So that was step 1. Find the GCF. Step 2 is divide out that GCF from each of your terms. So I'm going to do divide by x, divide by x. So looking here, 2 divided by 1 is just 2. Because your x down here has an understood coefficient of 1. So 2 divided by 1 is 2. If you have an x squared on top and an x on bottom, there's 2 on top, 1 on bottom. Cancel your pair. So I'm left with 1, where?
At the top.
On top. So this just becomes 2x. Do you need an exponent of 1? No, just like you don't need a coefficient of 1. Okay? If you have an x on top and an x on bottom, what happens? Anything divided by itself, though, is what? One. Anything minus itself is 0, but anything divided by itself is 1. So this becomes a minus 1. When I'm dividing, if everything cancels out, your term doesn't just disappear. If I had 2 terms and I'm factoring by removing the GCF, I still should have 2 terms. Okay? If I'm dividing by itself, that term is 1. We go with that? So that was step 2. We found our GCF. Step 1. Step 2, divide out the GCF. Step 3, write your answer as the GCF times the remainder. So I'm going to put this in parentheses, and the x goes out in front. Here's my answer. This is written as factors, 2 things multiplied together, x times the parentheses. Guys, this looks exactly like the problems I gave you last unit, right? What would we do with that x? Distribute it, right? That's what the whole last test was about. Okay, so last test I gave you something like this and your answer was simplified. Okay, meaning no parentheses and no like terms. Now we're going backwards. I'm giving you a simplified thing and I'm wanting you to put it in factored form, which means things multiplied together. Just like on the last test, when we were going from this to this, what could you do for almost every single problem? Check it on the... So if we're now doing the same thing but the opposite direction, what do you think we still can do for almost every problem this unit? Check it on the calculator. Let's do that. That's why about 40% of us got hundreds on part 1, or the calculator, the computer part of our test. because almost the whole entire test could be checked on your calculator. So we're putting our original in y1 and our answer in y2. Bobby, are you with me? Guys, are we struggling today because it's rainy outside? I don't know what's going on, but I see like 5 people with their eyes shut or asleep with their eyes open. We're doing this with me? So your fingers are all on the calculator and you're typing this all in with me? Non-optional. Let's go. Go to the table, and what do I notice about my columns? They're the same. That means we got it right. Yay. Okay, next. I have 1, 2, 3 terms. In order to find a GCF of 3 terms, all 3 of the terms have to have the common factor. First, look at your numbers. 3, 12, and 9. Tell me a number that 3, 12, and 9 are all divisible by. 3. Is that the biggest number they're all divisible by? Yes, because think, what's the only factors of 3? 1 and 3. Okay, so if 3 is a GCF, that's good. Do they all have an n? N squared and 9. If they don't all have an n, even though these first 2 have an n, is there an n in common with all 3 of them? No, so I do not have a GCF with a variable. It's just 3 is my GCF. So I completed step 1. Step 2, divide out that GCF. Divide by 3, divide by 3, and divide by 3. You are dividing all of your terms by the GCF. Okay? So looking here, what's this become? So the 3's cancel out. 3 divided by 3 is 1. That's correct. But then what am I left with? N squared. Looking at that middle term, what's positive 12n divided by 3? 4n. And it's a positive, so plus 4n. And then lastly, what's 9 divided by 3? And it's a positive, so plus 3. Put it in parentheses. And what goes out in front? GCF. Done. Now, one thing I will tell you, your calculator won't catch your mistake. If I put my original in and my answer in, it won't catch the mistake if you don't take out the GCF and you just take out a common factor. So once I get my answer, I'm going to look back in the parentheses and make sure there's not a GCF other than 1. Well, this only has n's and this doesn't have n's. So there's not a numerical GCF other than 1, and there's also not a variable GCF. So I know what I did by taking out the GCF of 3. I actually did take out the greatest common factor. Okay?
Wait, I'm confused.
So let's say you had a GCF of 3n.
Oh.
Okay, let's say this was n cubed, 4n, and 3n. If I typed this in the calculator of my original and then my answer where I didn't take out the variable common factor and I only took out the numerical common factor, it would still give me a correct, like, y columns. They would match. So that's why you need to make sure, once you take out the GCF, that there's not another GCF in the parentheses other than 1. Like, they don't all have an n. Or that they're not all divisible by another number other than 1.
All have an n.
Correct. Because if they all had an n, that would be in common, right?
Yeah.
And if it's in common, you should factor it out.
Okay.
Okay. Good? Next one. I have 2 terms. Look at your numbers first. What are 12 and 3 both divisible by? 3. Good job. Do they both have an a? A squared. Do they both have an a squared? No, this one only has an a. It doesn't have an a squared. So what am I going to take out variable-wise? A squared or just a? Just a. Very good. You can't take out more than every term has. If this term doesn't have an a squared, you can't take out an a squared. Okay? So there's my GCF. Factor out your GCF by dividing each term by it. So what's 12 divided by 3? What's a over a? Gone, right? You have an a on top, a on bottom, cancel out. No more a's. Okay, what's negative 3 divided by 3? Negative 1, but I'm not going to put the 1 there because if I have a squared on top and a on bottom, cancel out a pair and I'm left with a on top, 1a. So I'm just going to put a. Would it be okay if you put minus 1a? Yes, but again, you're never going to see me putting a coefficient of 1 unless, or you're never going to see me put a coefficient of 1. What's my GCF? That should go outside? 3a. Again, are we noticing that every answer I'm getting looks like a problem you got last unit? This is 3a times parentheses, so you would distribute your 3a to your 4 and you would get 12a. You would do 3a times negative a and you would get negative 3a squared. So this is exactly the same as what we did last unit, just backwards. Okay? My answer is simplified, or sorry, my original is simplified, and my answer is in factored form. Okay? Good? How are we feeling about these so far? Okay, I will tell you guys, factoring, like I said, factoring is important. Sometimes we struggle with it. You need to make sure you keep your work nice, neat, and organized. Okay, I always say that, but really when we're factoring. I have two terms here. Is there a number that 4 and 3 are both divisible by other than 1? No, 3 is prime, right? So 3 is only divisible by 1 and 3. Is 4 divisible by 3? No, so your only numerical common factor is 1. Okay? Do they both have an x? Do they both have an x squared? No, this one doesn't have an x squared. So if they don't both have it, you can't take it out. So what's my GCF then? Just an x. Very good. So when I take the x out, I'm going to divide both my terms by x. Looking at that first fraction, what's my coefficient? Bless you. What's the coefficient, guys? 4. Is there a denominator with a coefficient? There's an understood 1, but it's not written. So my coefficient's still just going to be 4. If I have an x squared on top and an x on bottom, what am I doing? Cancel out a pair, and I'm left with just x on top. What's negative 3x divided by x? The x's cancel, and I'm just left with negative 3. Very good. Then what should I do? Put it in parentheses, and what always goes out in front? Which is, there's my answer. Good? Okay, next. I have 1, 2, 3 terms. What are 10, 20, and 5 all divisible by? What number? They're all divisible by 5. Very good. Do they all have a y?
Yes.
Do they all have a y squared? No, so I can't take out a squared. I only can take out a y. We're doing this with me, right? Divide by 5y, divide by 5y, and divide by 5y. So do your numbers first. What's 10 divided by 5? If I have a y cubed on top and a y on bottom, cancel out a pair, and I'm left with y squared. Then I have 20 divided by 5 is, and it's a positive, so plus 4. And then you have y squared on top, y on bottom, cancel a pair, and you're left with y on top. Then you have negative 5 divided by 5. What's that? Negative 1. You have a y on top and a y on bottom. So the 5 on top, 5 on bottom cancel out. The y on top, y on bottom cancel out. Anything divided by itself is 1. And it's a negative 1 because it's a negative 5 divided by 5. What should I do now? Parentheses and put the 5y, which is your GCF, out in front. Good? Okay, last one of these, guys. Y'all are doing great. Last one of these. You never want to have a negative first term. Ever. Okay? You never want to have a negative first term. So, even if all of the terms aren't negative, if your first term is negative, you will always factor out that negative. Okay? Is my first term negative? So I'm definitely factoring out a negative, or my GCF is going to be a negative. Okay, always factor out the negative.
Should both of them become positive?
We'll get there. But if this first term is negative, always factor out a negative. Now, in this case, they are both negative, and I'm going to factor out the negative. What are 8 and 12 both divisible by? What's the biggest number? 4. Do they both have an x? Do they both have an x squared? No, so I'm just going to take out a negative 4x. So divide by negative 4x, divide by negative 4x. So what's negative 8 divided by negative 4? 2. That's right. Good job. You have x squared on top, x on bottom. Cancel a pair, and you're left with x on top. What is negative 12 divided by negative 4? Positive 3. You have an x on top and an x on bottom. What happens? They cancel each other out. So do I have any x with my 3? No, you had an x over an x. They cancel out. All the x's are gone. So then I'm going to put this in parentheses and put my negative 4x out in front. Again, why is this called factored form? Factors are things you multiply together. Here, I'm multiplying my negative 4x by my parentheses. That's why this is called factored form. Good? Okay, we are like halfway done, guys. Doing great. Now we are going to factor each by removing the common binomial factor. Do we remember from last unit what I said binomial means? What's bi mean? 2. Very good. So what's a binomial? 2 terms. There we go. 2 terms. So a common binomial is if you have 2 terms that are the same. Okay? Or a factor where 2 terms are the same. What do we notice looking at this first one? Is the same for both, right? The parentheses match. That is your common binomial. That's your GCF then. X minus 3 is your GCF.
Wait, so whenever you go to put your answer in parentheses and put your GCF out in front, will your GCF now be in parentheses too?
Is this in parentheses? So will you keep it in parentheses? Yes. Okay, so I'm going to factor out or divide out my x minus 3 just like we did whenever your GCF was only one term. I found my GCF, which was the parentheses x minus 3, your common binomial, so I factor it out, divide it out. The x minus 3's go away on both of them, and what am I left with?
7 negative 2x.
I'm going to put that in parentheses just like we did at the front. And then what's going to go in front of those parentheses?
X
In parentheses, your GCF goes out in front. Doesn't this problem now look even more like the ones we ended last unit with? 2 terms times 2 terms, do a double, distribute, or a 2 by 2 box. Okay? When we are multiplying, guys, does order matter? What's 2 times 3? What's 3 times 2? So when you multiply, does order matter? No. So if I flip-flop these parentheses, would it be the same answer? Yes, it would be, because order does not matter when we multiply. The only thing is it has to have the x and the minus 3 in the same parenthesis, and the 7 minus 2x together in the same parenthesis, but I could flip the whole entire parentheses. Like I could write it like this. These are the same answers. Either would be correct. Okay, we go with that? Do we like these even more? No, we don't. Next one, do my parentheses match? Yes, that means it's a common factor. Your greatest common factor. So my GCF is x squared plus 4. Divide out your greatest common factor. Gone, gone. So what am I left with? plus 1. Very good. This has a coefficient of 1. Anything divided by itself is what? 1. Just like I said on the front, you can't have terms that just disappear. If I divide out my common factor, my greatest common factor, I still have to have a term there. My term just changes. The value of my term changes, but it can't disappear. What's going to go in front? Does it need to be in parentheses? Yes. If it's not in parentheses, then you're just distributing the 4 and not the whole entire x squared plus 4, which would be a wrong answer. Good? Do my parentheses match? So what's my GCF? Divide it out. Gone. Gone. What am I left with then? What needs to go around it? And what goes in front? Done. Next one. Do my parentheses match? Womp womp. So can I take out a common factor of the parentheses? Do I have a common binomial? But is the whole... Look at the parentheses. Do the parentheses match, guys? No, if the parentheses don't match, you can't factor. That means your GCF is just 1. And if you ever have a GCF of just 1, it can't be factored. Now, if we are doing a whole entire unit over factoring, do you think it's going to be very common that we can't factor? Wouldn't that make life so easy? If I said factor this and you're like, oh, it can't be factored. Factor this, oh, can't be factored. Would we really be able to practice factoring then if I just gave you ones that can't be factored? No. But am I going to show you that some can't? Not everything can be factored. Now, again, if we are practicing factoring, do you think I'm normally going to give you ones that can factor? Yes. This is not going to happen very frequently where it can't be factored. Okay? Okay. Some of us have been not paying attention. We're all awake? If you've not been paying attention, I strongly encourage we start now with these last 4 problems. Okay? These are more common to what we are doing the rest of the whole entire unit. Okay? Factor by grouping. Okay? Here, how many terms do I have? 4. Do I see parentheses? So I don't have a common binomial factor. Okay, there aren't parentheses. Okay, is there a number other than 1 that they're all divisible by? What I would do is pick the smallest number. What are factors of 9? 1, 3, and 9, right? Get rid of the 1 because everything's divisible by 1. So I'm going to think of 3 and 9. Is 12 divisible by 3? Is 20 divisible by 3? No. So 3 is not a GCF. Is 12 divisible by 9? No. So there's not a numerical GCF other than 1. Do they all have an A? No. Wah, wah. The way we've learned how to factor, you can't factor this one. Okay, so we're learning a new method, factor by grouping. In order to factor by grouping, you need 4 terms. 1, 2, 3, 4 terms. You need to be in order. A squared, A constant. Okay, remember last unit I told you when you were writing your terms, I wanted you to get in the habit of going big exponent down to small exponent, but I didn't really care. Like I wasn't going to count it wrong if you didn't put it in that order. This unit, you have to put it in the correct order. Big exponent down to not even having a variable. Okay? So what does factor by grouping mean? I'm going to look at my first 2 terms. I'm grouping those. Pretend those last 2 terms don't even exist at all. So I'm going to rewrite my 12a squared minus 9a. Right, Troy? What are 12 and 9 both divisible by? Do they both have an a? Do they both have an a squared? No. So what's my GCF? 3a. So I'm going to divide both by 3a because that is your GCF. Are we okay with that? Now this is exactly like what we did on the front. So what's 12a, or what's 12 divided by 3? If you have an a squared over an a, cancel a pair and you're left with a. What's negative 9 divided by 3? Negative 3, and then a over a cancels out. What was my GCF? 3a. Put it out in front. Good with that? Now we're going to pretend the first two terms, all that work I just did, don't exist, and now we're going to group our second two terms, or last two terms. I have a positive 20a minus 15. What's your GCF of 20a and negative 15? 5. So I'm going to divide both by 5. Do they both have an a? No. So I'm just going to divide by 5 because that is your GCF. When I divide out a 5, what's 20a over 5? 4a. What's negative 15 divided by 5? Negative 3. Put it in parentheses, and what was my GCF? 5. What kind of 5? Positive. So I'm going to put a plus 5 to separate it from my parentheses in front of it. Huh! What do we notice now, guys? It's a common binomial factor. The parentheses match. If you are factoring correctly and your problem is able to be factored, once I get to this step, my parentheses should match. So just like we did up top, divide out the common binomial factor. Because again, that is now your new GCF. Well, the parentheses cancel and the parentheses cancel. So what am I left with? 3a plus 5. What's the GCF that should go out in front? 4a minus 3. And there's my answer. Could you check this in the calculator? Yes, you should. Okay, guys, every year, every unit, whatever that we now do factoring in, people complain, factoring's a long process. Yeah, I know it is, okay? Back in my day, when I was in algebra, there wasn't even a process for factoring. It was have good number sense, educated, guess and check, trial and error. Okay? So you might think this is a long process, but I promise you it's better than me telling you figure it out, which is what I was taught. Okay? Keep your work nice and neat and organized. It is a very procedural. First do this, then do this, then do this. Can you skip steps? No, and if you do, you're going to get the wrong answer. Okay? The good thing about them is every single one can be checked on the calculator. When would be the only time you can't use the calculator to help you? You have multiple variables. Okay? Now again, when do I know to use factor by grouping? How many terms do we need? 4 terms, okay? So let's go to this next one. Is there a numerical GCF other than 1? You have an x. Does this x even have a coefficient? No, so this has a coefficient of 1. So the only common factor could be 1, okay? Do they all have an x? No, this one's a constant. It doesn't have an x. So there is no GCF other than 1. So once you know that there's no GCF other than 1, I have 1, 2, 3, 4 terms. They're in the correct order, x squared, xx constant. I'm factoring by grouping. Look at the first two, pretend the last two aren't there. Yes, ma'am?
Can you only factor by grouping if they're in the correct order?
Yes, you would manipulate it to get it in the correct order. You have to have it big exponent down to no exponent.
So what if it wasn't in the correct order, though, could it not be factored?
you would manipulate it to get it in the correct order. So let's say I wrote 18x plus 2 plus x plus 9x squared. This doesn't mean it can't be factored. I would just rewrite this. Okay, what's my biggest exponent? 9x squared. It's going to go first. Then these two middle terms, the middle terms don't matter if they're both an x, okay? And then the constant would go at the end. Okay, so 9x squared plus 18x. What number are 9 and 18 both divisible by? 9. Do they both have an x? So there's your GCF.
I don't get it, because whenever you said like you're like 1 with your GCF, but now you're 9.
So whenever I looked at all 4 terms, my only GCF was 1. And up here, remember we said if your GCF is only 1, it can't be factored. So here, with my 4 terms, the GCF is 1. So it can't be factored, but we know now a new way to factor it. I'm going to group. I'm going to look now at just the first 2 terms. And now I'm looking just at those 2 terms, and those 2 terms have a GCF of 9x. Once I divide out my 9x, what am I left with? Plus 2. Very good. What was my GCF that should go in front? 9x. Very good. Now we're going to group our last 2 terms, x plus 2.
Real quick, I thought you had to put your GCF in a parentheses though.
Only when it was in a parenthesis. See, it's in a parenthesis here because they were in parentheses here. Here, my GCF wasn't in parentheses, so I didn't put it in parentheses. So if it was in parentheses, leave it in parentheses. If it wasn't in parentheses, you don't need parentheses around your GCF. What's my GCF of x and 2? 1. There's no number other than 1, and they don't both have an x, so they are both just divisible by 1. Well, when you divide by 1, do you change anything? No, so it stays x plus 2. Put it in parentheses, and my GCF goes out in front. But I need an operation sign to separate my 2 terms. If it's a positive one, I'm going to put a plus. Now I'm looking at it all back together. I group it, separate it, work them independently, then put it back together and work it all together. Do my parentheses now match? Divide by your GCF, which is your binomial, which is your parentheses. Well, when I do that, they cancel out. And what am I left with? Put it in parentheses, and what's my GCF? Now again, if I flip-flopped those parentheses, would that be okay?
Yes.
Do any of us like this? Because it's very it's pretty straightforward, right? Like, it's a long process, I know that, but you do this, 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 you're good. Okay? Follow the same process every time. Next, do I have a GCF other than 1? Looking at all 4 terms together, because that's always what we look for first. Before we group, you want to look and see if there's a GCF of all the terms. There's not, only 1. Do they all have an x? No. No. So we need to now make sure it's in the correct order. X squared, xx, constant. Yep. So factor by grouping. So 3x squared minus 15x. What number are 3 and 15 both divisible by? 3. Do they both have an x? Yes. So my GCF is 3x. When I divide out a 3x, what's left in my first term? Well, the 3's cancel. If you have x squared over x, what do you get?
X.
What's negative 15 over 3? And then the x's cancel. Make sure we're paying attention, guys. Some of us aren't doing this. Like I told you, this is one of the harder things we do all year. Because if you don't fully understand every step or pay attention the whole time, we might struggle. So I would make sure I'm paying attention. When I drop down my 2x plus 2x plus 10, what's in front of the 2x? Negative. So it's a negative 2x plus 10. Do we remember what I said on the front? We never want that first term being negative. So I'm definitely going to write out a negative. Okay, definitely divide out a negative. Then what are 2 and 10 both divisible by?
2.
That's a very common mistake. We a lot of times do 10 divided by 2 is 5. Be careful. Okay, so it's 2. Do they both have an x? No. So negative 2 is my GCF. When I divide out a negative 2, what am I left with? Minus 5, right? Put it in parentheses and our GCF goes in front. What do I notice? The parentheses match. You have a common binomial. So divide out your common binomial, which is your new GCF. So what am I left with? Put it in parentheses. GCF goes in front, which is what?
X minus 5.
Done. Are we ready for our last one? Okay. Do we have a GCF other than 1? And again, the way I do it is I take the smallest number, because that restricts what you can have. 4 is the smallest number. 4 is divisible by 1, 2, and 4. Which one we don't care about because everything's divisible by 1. Well, 15 is not divisible by 2. And 15 is not divisible by 4. So there's nothing in common. They don't all have a variable. So we have to make sure now we're in the correct order. X squared, x, constant. We're in the correct order, so factor by grouping. What are 15 and 10 both divisible by? Do they both have an x? Do they both have an x squared? No, so 5x is my GCF. When I divide out of 5x, what do I get? Negative 2. The x's cancel. Put it in parentheses, and what goes out in front?
5x.
When I group my last 2 terms, what terms am I grouping?
Negative 6x plus 4.
Be very careful. Include the negative with the 6. Okay, what's your GCF? First of all, my first term is what?
Negative.
So I know I have to divide out a negative. You never, ever, ever can have that first term being negative. Okay, what are 6 and 4 both divisible by? 2. Do they both have an x? No. So negative 2 is my GCF. Well, what's negative 6 divided by negative 2? 3, and it has an x. What's 4 divided by negative 2? Put it in parentheses, and what was my GCF? Do my parentheses now match? Guys, what are we noticing our goal is when we're factoring? We do all this work, and when we get here, what needs to always be true? The parentheses need to match. If your parentheses don't match, you are factoring wrong, or it can't be factored. Okay? Your parentheses must match when we are factoring. Cross them out, and what am I left with?
5x minus 2.
Put it in parentheses, and what's my GCF?
3x minus 2.
Done. Good?